Today we will be determining the propulsion force, or thrust, acting on a balloon and a toy car action-reaction pair. The balloon acted as the source of propulsion as the car drifted down a 1-meter track.
Okay. Yep.
We then analyzed the data using vid analysis. What you're looking at is a graph of the car's position over time, starting at the 0-meter mark. To find the force of the thrust, we need to use Newton's second law of motion. The sum of all forces acting on an object, F net, equals the object's mass, m, times acceleration, a. For this equation, we need to find acceleration. However, you'll notice our position graph is pretty linear. This means we have a constant velocity, and therefore our acceleration is 0. Looking at a force diagram of the object, we see the forces present are weight, normal force, thrust, and drag. We can ignore weight and normal force since they don't have an x component, and focus only on thrust and drag since they're pointing along the x-axis where motion is happening. By setting acceleration and therefore the whole right side of the problem to 0, we can determine that thrust is equal to drag, which makes sense. Since the forces are pointing in opposite directions, they would need to be equal and opposite and sum to 0 for there to be no net force acting on the car, and therefore no acceleration. The balloon is the main source of drag, since it's facing the direction of motion and blocks the entire car for most of the drive. The equation to find drag is 1/2 times the density of air, rho, times the cross-sectional area of the object, a, times the drag coefficient, c, times the velocity of the object squared, v. Velocity is defined as an object's change in position, x, over time, t. Looking at the position graph we made earlier, the car traveled 1.032 meters in 1.399 seconds, giving us an average velocity of 0.738 meters per second. Now we found all we've needed to start plugging things into our formula. Air resistance typically has a value of around 1.2 kilograms per cubic meter. Since the balloon is a sphere, its cross-sectional area is pi times the radius squared. The diameter was 16 centimeters, making the radius 8 centimeters, or 0.08 meters. The typical drag coefficient for a sphere is 0.47, and the velocity we just found was 0.738 meters per second. Plugging that all in gives you a drag force of 0.309 newtons. Since earlier we discovered that thrust and drag are equivalent, our propulsion force is the same, 0.309 newtons.